Hi, I'm John Murray with Reed Business Information. We're in Chicago at Manufacturing Week, and I'm with Alan Bandes, one of the exhibitors at the show. And Alan, you are exhibiting here what particular product?
We have the ultrasound inspection products. The main series is the UltraProbe series, which are used for mechanical inspection, leak detection, and electrical inspection.
Okay. Now, the plant engineers and plant managers walking the floor here today, what are some of the applications they'd be using your product for?
Well, the whole thing is, in any plant really, generically, is uptime. You want to prevent unplanned outages due to equipment failure. So you want to make sure your assets are working properly.
Unplanned failures, that saves a lot of dollars.
A tremendous amount.
Okay.
It's not just the cost of the product, it's everything associated with the product that can go wrong.
Okay.
So what we can do is get early warning of mechanical failure, predict a problem through ultrasound. And the advantage of ultrasound, being a shortwave high-frequency signal, is that we can isolate the sound exactly on the location of the indication.
I understand.
And by that, we can either detect it or trend it over time. And find out when is the best or most opportune time to take action and plan that action so we're ahead of the game.
Prior to downtime.
Prior to downtime.
I understand. Okay.
The other avenue is, as I had mentioned, energy conservation. As an example, we have over here some examples of pneumatics. All right? We can pick up compressed air leaks. Why are compressed air leaks so important? Compressed air just basically sits there. All right? The U.S. Department of Energy has indicated that compressed air is the most costly utility in a plant today.
Wow.
In fact, they have a compressed air challenge that they've been issuing to industry to try and reduce the use of compressed air. Finding leaks is one of the most opportune ways and actually one of the most cost-effective ways of doing this. Just to give you an example, this is a compressed air chart performed by a survey in which it's based on 100 PSIG. 22 cents a thousand cubic feet was the cost over a year. Now, if you look at the diameter of the leak, when you look up here at a 64th of an inch diameter, we move it over to the loss per year, it's only $48. But if we look at larger leaks, come down here, 3/8 of an inch leak. Nobody in their right mind is going to have 3/8 of an inch leak, right?
Right.
Wrong. It's very common, unfortunately. Look at the cost.
Wow. That's substantial. And not only is it a dollar savings, too, it's a safety issue as well.
It's a safety issue. We're not just talking air leaks here. We can talk about any kind of gas.
Right.
We can pick that up.
Okay.
And, of course, the other avenues that we are talking about, predictive maintenance, we talk about the mechanical operations. One of the big issues here we call condition-based lubrication, predictive lubrication. Up until now, most lubrication issues are what we call in the mode of preventive, such as with your oil change.
Exactly.
You're told every 3,500 miles, change your oil.
Right.
Well, with bearings, they're told after X number of hours, grease.
Right.
There could be situations where a lot of these bearings don't need the grease. Now, just adding grease on when it's not needed creates an over-lubrication condition.
Right.
Over-lubrication is one of the most costly, or most common, I should say, issues of bearing failure. It's one of the most common causes of bearing failure.
Understood. So your monitoring equipment, again, can focus in on exactly wear time and whether or not a bearing is, in fact, needing lubrication at that point.
Correct. And, of course, related to that, we can also determine which bearings not necessarily need lubrication, but need attention because they're approaching the failure mode. And that's what we can do over here. We can check out the bearings.
With each of these inspection types, how would you tie this together in a program where someone... Software. Of course.
There are two types. There's spectral analysis software in which we can look at a spectrum. As you can see up here, there's an example in one of our sheets where we have overlays of 3 electrical phenomena, arcing, tracking, and corona, and we're able to see them. Or, if we wish, we can look at it in a real time and hear it as well as see what's going on.
You can hear it.
In the software that we have, when you play it back, you can actually record off of our UltraProbe 10,000.
I understand.
You have onboard recording. You can record the sound, download it to your computer, and analyze it immediately.
Okay. Excellent.
The other advantage is we can also data log the information and have total management of our data.
Okay.
We can analyze over time, we can see trend issues, we can create reports, charts, and graphs.
And again, trending issues are going to lead to less downtime, savings, and some safety.
Absolutely.
Alan, thanks for your time. Alan, thanks for your time.